Hello again, I'm Sasha and this is the third video for UniSQ MTR1201 Millie's Flying Fish assignment, Sensors, Implementation and Hardware. In parts 1 and 2 we designed and wired everything up, then did some simple testing and got the server working well. In this section however we'll be focusing on setting up the MPU 6050 IMU sensor via I2C and getting some basic measurements. Specifically, we are asked to A. Create a program to show raw data from the IMU alongside calibrated and converted data. B. Design a flowchart for the program and provide a brief explanation of the code. And C. Place an object with marked angles below the fish and perform some tests and comment on the received data and next steps. The code for this module is a little more complicated than that used in part 2, but it's still pretty simple. At the top we import the required libraries, then create the MPU sensor object and define some values. Next we set up the serial and wait for it to initialize, then set up the sensor and set the gyro range to plus or minus 250 degrees per second and the accelerometer range to plus or minus 2 Gs. We then use a for loop to get the dataset of the x, y, and z gyroscopic values from the IMU and average each axis to calculate the bias. Now moving to the main loop, we first read sensor values again and this time convert them from raw signed 16-bit sensor data to Gs of acceleration and calibrated degrees per second of rotation by multiplying by the conversion factors defined at the start and subtracting the gyroscopic bias values determined before. These conversion values can either be looked up in the datasheet or calculated from the ranges set before and the fact that the sensor outputs signed 16-bit data, as shown on screen now. We then print both the raw data as well as the calibrated and converted data via serial, then wait for 200 milliseconds between loops as to not flood the logs. Now that we're done with the code, we will move on to the tests. For this module we're just asked to show the required IMU values being captured, so I'm going to spin the fish around a bit and show the required gyroscopic data. We can also look at the accelerometer values to see if it picks up gravity accurately. Spinning the fish, we can see the raw x rotational data change along with the converted value. The sign of the data changes when we rotate in the opposite direction, as expected. The produced values are appropriate for the speed I'm rotating the fish as well. In the next video we will integrate this value to calculate the angle of the fish from the rotational momentum currently shown. We can also see the accelerometer works and shows roughly 1 G in the x-axis when stood up. This concludes part 3, thanks for watching.